Hello everyone, welcome back. This is Engineer Hussein Wasabi. Alright, so in this video we'll be looking at what are known as binary operations. So before we begin, do not forget to like, subscribe, and hit the notification bell icon. Alright, so let's begin. So what are binary operations? So by definition, you can understand that binary operations can be illustrated in this manner. And this manner tells us to say that if we have an operation, it implies that an operation is said to be binary if star is a binary operation in a set A. And if A and B are a member of set A, such that an operation of A acting upon B gives an element that is part of set A. Now, this definition will not make sense right now, but I need you to bear with me. Now, when it comes to certain operations that we have in mathematics, you'd find that we have operations under binary where you have maybe A star B, or maybe even C star any other letter, or even X. This is an operation. Now, this operation is said to be binary if and only if the elements that are in the operation results into a value that is part of the set that is in question. That's why an operation is said to be binary if star is a binary operation in a given set such as set A, and if A and B are members of that particular set. In the sense that if I create an operation where A is acting upon B, where I say A star B, needs to give me an element that is part of set A. I hope that's clear. Now, under binary operations, we have certain things we need to understand, and these things are basically laws. Now, what are these laws? Now, the first law we need to know is the commutative law. Now, for the commutative law, it states that A star B is the same as B star A. So, if an operation is given in the form of A star B, it doesn't necessarily mean that if I change the order, I will not have the same thing. But if I end up having the same thing, it means that what I have is a commutative law. And there will be questions where they'll ask you to say, is the operation commutative or not? So, if the order in which A and B is placed doesn't matter, it means that that particular operation is said to be what? Commutative. But if it doesn't hold true, then it means that that operation is not commutative. The second law is the law of association. So we'll look at the associative law. So associative law. Now this is like multiplication. It means that A star B star C is the same as, say I multiply A with B first. The same as one having A star B star C. So if this holds true, it means that the operation is said to be what? Associative. Now, let us try to understand these binary operations with an example, or examples to say. Alright, so let's begin. So given that star is a binary operation on Z, of which Z is a set of integers defined as such. Now, we need to answer the following questions, in which the first question is saying, is star commutative? Alright. Now, let's first understand the operation that we have. The operation that we have is that A star B is equal to A minus B squared plus 2AB. Now, what you need to understand is that for this to be commutative, it means that A star B should equal to B star A. Now, how do you determine B star A? Because we already have A star B. Now, how do we find B star A? Now, let me make you understand with, let me just give you a hint. So, in a sense where I ask you to say, find B star A. Say data on the side. Let's say I want you to find B star A. Now, when it comes to B star A, what you just have to do is simply place B where there is A and place A where there is B. You just change the operation, but you do not tamper with the sign and order of the operation. What I'm trying to say is this. If I want to find B star A, let's focus on the operation given. We have A star B is equal to, open parenthesis, A minus B squared plus 2AB. So for me to find B star A, this will simply be, wherever there's A, I'll put B now, because the order is now B, then A. So it's going to be B minus A squared plus 2BA. And that is B star A. Now, I want you to try this one. Let's say I give you something like C star E. How is it going to come out? So, C star E will simply be, so I'm starting with C, then minus E squared plus 2CE. What of if you have something like, let me not say Z, let me say X star 2. So I'm starting with X, then minus 2 squared plus 2, then X, then 2. That will be the order. What if you have something like 1 star 4? This means that I'm starting with 1, then minus 4 squared plus 2 times 1 times 4. This is how you create the operations. Now, this means that if B star A results into that, then if I am having A star B, we know that A star B is A minus B squared plus 2AB. This is A star B. Now, what will B star A give us? B star A was found initially there. B star A gave us this value here. So let me pick it from there. This is B minus A squared plus 2BA, like that. Now, is this one and the same thing? Is it one and the same thing? Now, what you need to understand is this. B star A can be written in a way that could make more sense. Because others, just by doing this, could conclude to say, no, it is not what? Commutative. But what I want you to understand is this. Let me show you something. Now, since we know that B star A is equal to is equal to B minus A squared plus 2BA. Now, we can start simplifying this. So, B star A is equal to B minus A squared. Then, plus 2. BA is the same as AB to start with, isn't it? So, once we know that, we can also conclude to say that B star A is the same as 1 writing. Now, when it comes to multiplication, there are basic orders we need to remember. Now, this here can also be written in the form of, let me use a square bracket and say minus 1, then, because if I put a minus from that, I'll have minus B plus A, like that, then squared plus 2ab. Mathematically, we are allowed to do this. Therefore, b star a is equal to, now the power will be shared with all the elements within the brackets. So this will be minus 1 squared, then minus b plus a squared plus 2ab. Therefore, b star a is now equal to, now negative 1 squared is 1, then you have, now this can be written in the form of a minus b squared plus 2ab. Therefore, you have b star a being equal to a minus b squared plus 2ab. And this will basically be the value of b star a. Now, going back to our basic operation, trying to say if star is commutative. Now, we know that a star b is this. Now, b star a has now been found to be this value here. So we'll say is equal to a minus b squared plus 2ab. And basically, if you look on your left hand side, this is your left hand side, comparing it with the right hand side, you will find that these are equal. Therefore, we'll say that star is commutative. Just like that. So this is basically how we answer a question phrased in such a manner. Alright, so let us try to solve another question. Now, in the same question, let's say we're being told to evaluate 2 star b and 2 star 4 and 4 star 2. Alright, let's try and do this. Okay, so we have an operation that we are following, which is a star b being equal to a minus b squared plus 2ab. Now, let us find 2 star 4. Now, in this operation, we'll basically follow the procedure. So I will put 2 wherever there is a and 4 wherever there is b. So this will be 2 minus 4 squared plus 2 times 2 times 4. Therefore, 2 star 4 will give us, now if we do our computation here, we find that we have 4 plus 16, which will give us 20 as our answer. And if we try and find 4 star 2 from the operation that we already have, which is a star b being equal to a minus b squared plus 2ab. This simply means we'll have 4 minus 2 squared plus 2 times 4 times 2. Therefore, 4 star 2 is equal to, if we compute this, we'll have 2 plus 16. This will also give us what? 20. So now, if you see 2 star 4 is the same as 4 star 2. And this simply means that the operation proves true when we say that it's what? Commutative. Just by even evaluating our given what? Values. Now, we're not actually told to prove if it's commutative. We've just been told to evaluate. And just by you finding 20 on this operation, and that operation means that you have actually solved the question. Now, I'm just trying to make you understand that this holds true, that the operation that we have in question is commutative. Let us also try to solve another portion of this same question. Let's say we have been told to now evaluate this here. Now, whenever we are operating this type of questions where we have, let's say, 3 star 5, then star 7, remember we have to follow a board mass. We have to start with the brackets first. So I first have to find the value of 3 star 5. Now 3 star 5, remember our operation is here. This is the operation we're working with. So 3 star 5 is equal to 3 minus 5 squared plus 2 times 3 times 5. Therefore, 3 star 5 is equal to, now if I compute this, 3 star 5 will give me basically 4 plus, should be 30, because this will be 6 times that, so it will be 30, and this will give me 34. Now that we have the value of 3 star 5, it now means that we have 34 being operated on what? 7. So using the basic operations, the operation that we're working with in this question, it means that we're going to follow this order of us saying 34 minus 7 squared plus 2 times 34 times 7. And this basically will give us, so 34 minus 7, this will give us 27 squared plus, this will give us 64, 2 times 34, that is 68, sorry. Then times 7, this will give us 1, 2, 0, give us 5. So that is basically the answer on this operation. Now, this basically implies that 3 star 5 star 7 is equal to 1205. So that is basically the answer that we have. Now, other than that, we need to also find this other portion here. Now, remember, we also have to start with brackets again. So I'll start with the data and look for 5 star 7. Using the operation, that operation means that I will have 5 minus 7 squared plus 2 times 5 times 7. And 5 star 7 is going to give me a value of 74. Now that I have 5 star 7, I can operate the value of 5 star 7 onto 3. This implies that 3 star 74 will give me 3 minus 74 squared plus 2 times 3 times 74. And the operation of 3 star 74 will give me a value of 5,485. And that will be our value. That is if we compute this algebraically. This means that the operation that we have in question as 3 star of 5 star of 7 is equal to 5485. And this here is our answer 1, and this here is our answer 2. Now, C is telling us to say, is star associative? Now, star is not associative simply because if you look at the operation that we have in question, 3 star 5 star 7 is not really equal to 1 having 3 star of 5 star of what? 7. So it is not what? Associative. Not associative. Just like that. I hope it is clear. Now, one thing you should remember is this, that when you have such questions, always use that technique in solving them. All right, so let's look at this other example that we have in question. You can always pause the video and try to attempt this question on your own and see if you can answer. All right, so let's begin and let's see if we can solve this question together. All right, so it says consider the binary operation star defined by that operation. So we're working with the operation which is saying x star y is equal to x squared plus y squared minus 2. while x and y are real numbers, determine whether star is commutative. Now, for star to be commutative, we know, so for the first portion, for star to be commutative, we know that x star y should equal to y star x. So we already know what x star y is, and we know how to find y star x. So x star y is simply x squared plus y squared minus 2. What of y star x? This will simply be equivalent to sorry, y squared plus x squared minus 2. Now, are these quantities the same? They are the same, because x squared plus y squared minus 2 is the same as, now this portion here can be written as x squared plus y squared minus 2. Therefore, star is commutative. And that's how we answer it. Now, they're saying determine whether star is associative. Now, this portion for solving associative is also a bit tricky, but with a little bit of practice, you get the hang of it. Now, we need to create an operation that will make sense. So this operation needs to be phrased in a manner where we need to have three entities. We have x and y, but we need another value. So, let us now introduce another value, z. So let x, y, and another variable, z, be a member of all real numbers, such that if I want to determine this law, the law of association, it implies that x star y star z should be the same as x star y star z. So this is my left hand side, and this is my right hand side. Let's see if these will result in the same values. So for the left hand side, I already know that I will have something of this sense. We will have x star y. So x star y is, let me just do data for easily understanding this. So let's do x star y star z. So x star y, we already know that this is x squared plus y squared minus 2, then being operated on z. This implies that if I operate this on z, I will have x squared plus y squared minus 2 squared plus z squared minus 2. And this will be what I will end up getting for my right hand side. Now, I don't necessarily have to follow it out, unless if you want to follow it out, but I won't. Then the next data is for the right hand side. Now remember, we have to always begin with the brackets. So let us find y star z. So y star z, from the operation that we're working with here, or in the question, you will know that we will have y squared plus z squared minus 2. And now if I consider this value that I found and operate it on x, I'll be having y squared here plus z squared minus 2. Now, operating x on that means that we'll have x squared, then where there is y, I'll plug in this, and this would be y squared plus z squared minus 2, and this would be squared, then minus 2. Now, as you can see, the right-hand side, the left-hand side is not equivalent to the right-hand side, because this doesn't look anything close to this. Therefore, since the left-hand side is not really equal to the right-hand side, star is not associative. So basically, that's how you go about solving this portion. All right, so now we need to solve the evaluation problem that we have there. It's 3 over 5. So this is basically 3 over 5. Okay, so we're having 3 over 5 star 2 star 5. If I'm not mistaken. 3 over 5 star 2 star 5. All right. So having 3 over 5 star 2 star 5. Let's start with the brackets first. So data. What is 3 over 5 operated on 2? Remember, the operation is A star, not even A, it's X actually. So this is X star Y being equal to X squared plus Y squared minus 2. Therefore, 3 over 5 star 2 will be 3 over 5. This will be squared, then plus 2 squared, then minus 2. Just like that. Now, this basically can be simplified. You can have, now this is the same as one having 9 over 25 plus 4 minus 2. Now, the same as one having 9 over 25 plus 4 minus 2, that will give you a 2 over 1. You will have common denominator 25, and you have 9 plus 50. So you will have 3 over 5 star 2 resulting into 59 over 25. From there, we can pick it up and say 59 over 25 operated on what? 5. And this will give us 59 over 25 squared plus 5 squared minus 2. Therefore, 59 squared will give us 3,481 over 25 squared will give us 625. Then plus 25 minus 2. 59 over 25 star 5 is equal to, now this basically, I'll just say over 1, then over 1, then look for a common denominator, which would be 625. And I'll basically have 3, 4, 8, 1 plus 20. Nope, I won't be 25. That would be 1 that is that times that. That will give us 1, 5, 6, 2, 5. Then minus 1, that will also times that. Will give us 1, 2, 5, 0. So this is just basic algebra. I hope no one is lost here. So if I do my computation right, I'll have my final answer to be equivalent to 17856. This is over 625. Therefore, I can conclude that 3 over 5 star 2 star 5 is equal to 17856 over 625. So this would basically be my answer for the evaluation. All right, I know this might be a handful when it comes to binary operations, but trust me, if you practice these over and over again, try to solve the same problems over and over again, you get a hang of it, and you'll find that it's just literally the same thing that you'll be doing in most of the questions. in most part of the questions you come across, questions that will be highly phrased are questions where they'll ask you to say, is this associative? Is this commutative? Evaluate this. Is this binary? And the like. All right. Let us now try to solve this question here. Now, this question simply says that let star be a binary operation on real numbers defined by that operation. So we have it defined as x star y being equal to x plus y over star minus 3. Now, our first question says, is star associative? Now, if star is associative, it means that if I let x, y for associative, or for the associative law, I need another variable. Let's introduce z, which is a member of all real numbers. It implies that x star y star z is the same as x star y star z. So this is my left-hand side, and this is my right-hand side. So I can do up a data for my left-hand side. So using the operation given in question, x star y is given as x plus y over x, so minus 3. Therefore, x plus y over x minus 3 star z will give us x plus y over x minus 3. Then this will be plus. So wherever there is the other variable, which is y, I will put z. So this will be z over the first variable, which is x plus y over x minus 3. Like that. And this is minus 3. So this is for my left hand side. Then for the right hand side, we're having the operation, which is here. So y star z, this will give us, basically if we do our operation right, we'll have y plus z over y minus 3. Now we can say x operating on y plus z over y minus 3. And this will give us x plus y plus z over y minus 3 over x minus 3. And this is our right hand side. Now, as you can see, the left hand side is not equal to the right hand side. Therefore, we will say, or conclude rather, that star is not associative. Star is not associative. Then we have the evaluation problem there that we have. Do it on the other side. All right, so the evaluation problem is saying that we have 3 over 2 star 9 over 4 star of minus 3 star 6 star 5 star 10. This was too much. But anyway, let us try and solve this. Remember, the operation is that we have x star y being equal to x plus y over x minus 3. All right, so let us do the brackets part first. Okay, so data. Let us find 3 over 2 star 9 over 4. This will give us 3 over 2 plus 9 over 4 divided by, I hope you know I've put division because of this part here, divided by 3 over 2 minus 3, which will give me 3 over 2 plus 9 over 4, division turns into multiplication, times 2 over 3 minus 3. This will give us 3 over 2, 2 there 1, 2 there 2, 3 there 1, 3 there 3. So that will give us plus 3 over 2 minus 3. Say over 1. Common denominator is 2. So this would be 3 plus 3 minus 6. So 3 over 2 star 9 over 4 is equal to 0 over 2, giving us 0. So this is for the first portion as data 1. Data 2, we're having minus 3 operating on 6. This will give us minus 3 plus 6 over minus 3, then minus 3. This will give us minus 3. Then minus 3 into minus 6, that's minus 2 minus 3. So it's minus 2, then minus 3. So minus 3, minus 3, minus 2, that is going to give us, so this is 3, 4, 5, 6, 7, 8. So this will give us minus 8 for that operation. Then if we do that 3, we're having 5 star 10. And this will give us 5 plus 10 over 5 minus 3. This will give us 5 plus 2 minus 3, giving us 7 minus 3, giving us 4. Now that this is simplified, we're now having this 0 star minus 8 star 4. So I can operate this first and work on 0 star minus 8. This will give me, since the operation is here, I'm having 0 plus minus 8 over 0 minus 3. All right, so now since I've just reaching here, can literally even tell you that we're not going anywhere, because I'm having 0 at the bottom, and having 0 at the bottom simply means that this is going to be undefined. Therefore, we won't really even have any solution for this. Therefore, I'll just end here. I'll just end here and I'll conclude, because this is undefined. And if any portion is undefined in your evaluation, just know that you won't have any answer. Therefore, the operation that I'm having as 3 over 2 star 9 over 4 star of minus 3 star 6 star 5 star 10 is undefined. If you don't want to write undefined, you can simply just say this has no solutions, and you'll be marked. Basically, that's how it works. So now that we have solved this portion, let us also now go back and solve the remaining portion. Does R have an inverse with respect to star? Does it have an inverse with respect to star? So let me just erase this so I can just answer on this part. Okay, so I want you to understand this. I want you to understand this in an easier way. So to determine if it has an inverse with respect to star, we first need to determine if the operation on R has an identity with respect to star. So does this operation have an identity? Let's try and do that. So let's let some random variable e be a member of all real numbers. Now, this e, which is a member of all real numbers, let's take it to be what? The identity. Once we do that, let's also pick another variable, a, and make it a member of all real numbers, and just be any other element. Therefore, to determine if this has an inverse, we need to check if it's commutative. So let's try and see if a star e is equal to e star a. Now f star e is going to be equal to a plus e over a minus 3. Then e star a will be e plus a over e minus 3. Basically, as you can see, these entities are not the same. The left is not equal to the right. Therefore, the set R does not have any identity. So we say it has no identity, which implies that it has no inverse. So that's how you go about solving such questions. All right, so this is everything you need to know about binary operations for now, but there are a lot of questions. I'd advise that you find as many questions, try to attempt them. If you have any queries, you can reach out to me on WhatsApp on the line 077 149 5252. But trust me, like I said, at first glance, this might be a handful, but with a little bit of practice, going through these examples over and over again, you literally have 89 or 90% of the knowledge of the binary operation or questions that might be phrased on your test, quiz, or even the exam. All right, thanks for watching. Remember, slow progress is better than no progress, and let's strategize before becoming a statistic. Try and push for that A+.